In the first lecture hour today, we discussed general topics regarding test automation, unit testing, integration testing, and various other test forms. And now I would like to give you a quick introduction into how you write professional unit tests in C#. And next week we are going to take a look at writing tests in TypeScript. So in C#, there is a certain project type in Visual Studio which is very well suited for the development environments that we use here in this course, especially ASP.NET Core. And this framework, it's called xUnit. So please follow along and create an xUnit test project. Okay, please do that. You can give it a name. I will call it, I don't know, my first unit tests, something like this. My first unit tests. We'll take .NET 6, of course, as always in this course. And that will give us a new project with xUnit. Please do that. Please follow along. Okay, very good. Yeah, we have done some tests a little bit in previous exercises, but I think not enough. So therefore, this is an important topic here. You see, that is an xUnit project. If you take a look in the csproj file, you will see that this xUnit project has a bunch of dependencies. The core dependency is the testing framework. It's called xUnit. By the way, of course, there are other testing frameworks too. Every programming language has multiple unit testing frameworks. It's the same for TypeScript, it's the same for .NET, it's the same for Go, it's the same for Rust. There are many different unit testing frameworks, and here we use xUnit. xUnit is also used by Microsoft itself for building .NET. So it's a very widely used unit testing framework here in Visual Studio and in C#. It is not bound to Visual Studio, don't get me wrong. It's not bound to Visual Studio, so you can run it on Linux, you can run it on Mac, you can run it in Visual Studio Code, you can run it in the command line. It's completely platform independent and 100% open source. Now the next one here is really related to Visual Studio, same is true here. If you install these packages, you get particularly good support for xUnit tests in Visual Studio and in the Visual Studio product family. What do I mean with that? Let me show you a bunch of examples. And one thing that is particularly interesting is the so-called Test Explorer. If you have it on the left-hand side, you can simply turn it on. You can also use the search box up here to look for the Test Explorer. You see it? You will find the Test Explorer here. And the Test Explorer will give you a list of all the tests, and you can simply right-click it and run them. Just try it in the Test Explorer, hit run, and it should run the unit test, and it should turn from this exclamation mark to a green check if everything works properly. It runs on my machine now, and you see now I have a green check, everything is fine. You can also use this icon directly on top of the test to run or debug the corresponding test. So these are the things that you get from the NuGet packages that you can add to the csproj. Well, they are added automatically, as I told you. The coverlet collector is an interesting one, but I will not go into detail now. I will show you that a little bit later, okay? So let's quickly take a look at such a test project. Technically, a test project is a class library. So you create a DLL, it's a test project, a separate test project, and this test project in our course, of course, is .NET 6. That's fine. The test project consists of a bunch of classes, and inside of the class you have a bunch of methods, and on top of every method you have this this attribute here on top. This attribute is called fact. It comes from xUnit, and it marks a method as being a test. So if I create the second method here, test2, this is not considered a test, but if I add fact here, I have a second test. You see now you have two tests. If you go here, two tests, we can run them and we get two green checks. So everything is fine. This is the important one here. So with the new version of Visual Studio and C#, I personally restructure the xUnit projects a little bit and this is not mandatory, it's completely optional, but I would like to show you this as a kind of note or tip if you want. What I typically do if in a unit test project, I create a lot of different classes, and in the classes I group my tests logically. So I will have to write this using xUnit all over every single C# file. So what I typically do is I add a new file, in this case a class, I call it usings. I delete everything and I simply say global using xUnit. See? And by adding the global using here, I can remove the using xUnit inside of all my separate unit tests files. Additionally, I personally do not like these curly braces around the namespaces, so what I typically do is I put a semicolon at the end of the namespace declaration and remove this one, and with that I can get rid of the indentation and the additional curly braces. I think this is more clean and clear to read. But those steps which I showed you now are not mandatory. They are completely optional. So if you like the structure of this file, you can do it like that. If you are happy with the existing structure that Visual Studio created out of the box, feel free to keep it as it is. It's completely up to you, okay? Now let's dive into testing. Let's do some very simple examples. Let's create a second project in our solution by right-clicking on the solution, hitting Add, New Project, and let's add a class library. We want to test the class library. I will call this the Great Math Library. Very, very simple. The Great Math Library. You can give it a different name if you want, but it's fine if you use it like that. Again, the usual stuff. I remove the curly braces to get rid of the indentation, and then I rename the class 1 to Basic Math. See? Now my class is called Basic Math. I will not store any state here, so I can make this class static. Just for now, we'll discuss more complex scenarios either today or next week. And we'll add a simple method. Public int add int x int y, and the business logic for the add method is super complicated. Exactly. Return x plus y. I forgot the static, and then the error should go away. Now what could be acceptance criteria for that? If we add 1 and 2, the result must be 3. So let's write this test. It will be very simple. First, we rename the unit test class. I will call it test basic math, because this is what it does. It tests the basic math functionality. Then I call this one add var result equals to basic math. Oh, it's not available. Basic math is not available. Obviously it's not available, because now I have my business logic in the library and I have my test here in a separate library, which is the xUnit library, so I have to add a new project reference here. So the test always references the project that should be tested. And now basic math should be available. See? Now it says using Great Math Library. And because we will use all these functions of Great Math Library all over the place by nature, because we are testing this one, I will again cut this one, put it into my global usings here, global using Great Math Library, so I do not have to add the using Great Math Library over and over and over again. I just put it in a simple file, and then I can add as many classes as I want, and I do not have to bother about writing the using. So let's do the add 1 and 2. We add 1 and 2, and now we have to check the result. And you see, if you use Visual Studio 20 22, you get pretty intelligent IntelliSense. Visual Studio says, hey Rainer, I guess you want to write an assert equal statement. I didn't write that one. Visual Studio suggests that. So I can just hit the tab key and it will add the assertation. Assertation means that it checks whether the result is equal to this expected value. Obviously, Visual Studio didn't come up with the correct answer. The answer, of course, should be 3 because 1 plus 2 is 3. So that's perfectly fine. So if we have that one, we can simply run it. See, run it and it will produce, obviously, a green check. Green check, that's fine. We can go into basic math and screw something up by saying minus, run it again. Of course, you can guess what will happen. It will tell us that this is broken. I can go back to my code here and I will also see that this method is tested by one test method. This test method is currently broken. I can use the debug all to run the debugger, find the mistake. I can fix that one here, go to the plus again, rerun the unit test, and then everything should be fine. So every unit test consists of 3 things. First, you have the input data. Second, you have the expected results. And third, you have the business logic which transfer the input into the result. And you have to check whether the result is equal to or adheres to the expected outcome. Now I would like to show you the next step, because sometimes we have to test with different input sets. I mean, this method is kind of trivial, but that's the point. We want to learn unit testing, not write the most complicated business logic here. So what I want to do now is I want to write a different add test. So let's say add second scenario or something like this. Then we can copy this guy here. We put it here, and in a more complicated scenario, we could maybe say, well, now we try it with larger values, something like this, and we will see whether this works with larger values. But can you imagine that writing tests like that is kind of boring? Adding the same input values, writing the same code again and again and again, it's not the most beautiful thing. So therefore, xUnit offers us a second type of test which you will use pretty frequently. Let me show you how that works. Let's rename the test to add theory. And let's change the fact attribute to the theory attribute. Now let's add 3 parameters to our method, add theory. Int x, int y, int expected result. And now we can do a very interesting trick. Visual Studio will immediately suggest something like this, inline data. Of course, 1 doesn't make sense, but we can now add 1 and 2 and 3. This is the input data, x and y, and this is the expected result. We can copy this line, and in the second line we say 1000, 2000, and 3000. And down here we can now change the values to x and y, and here expected result. So now with a single method and using a theory with inline data, we can run a single test with multiple data sets. And this is really, really useful in practice. Now if we go to Test Explorer and run everything, you will see that the add theory now has 2 different executions. See? We have on the one hand side the add theory with 1, 2, 3 and the add theory with 1000, 2000 and 3000. So remember that, using a fact for a simple test which does not get any input parameter, and theory for providing input data and expected results using the inline data attribute. And then you can add some parameters here, and they reflect to the parameters up there. There are even more advanced scenarios with xUnit. You could read this data from a database. You could parse a text file containing some test data. You can do really interesting things with these theories. But we will keep it with that. Now that you know what a theory is, you have the necessary keywords to do a proper Google search if you ever want to read this data from a database or from a file. Let's try a more advanced example. Let's again go into our great math library, and in this great math library we will add a new class. Let's call this class, for the sake of this demo, let's call it Numbers Reader. As usual, we restructure the code a little bit. So remove the usings, remove the indentation. If you want, you can keep it as it was if you like that more, but for me it works perfectly fine. Let's make it a public class. For now, that's perfectly okay. And this numbers reader here offers a certain functionality. I will demonstrate what that does. For that, I will add another file, a text file, here, text file, and I will call it, you can guess it, numbers.txt, 1, 2, 3, 4, 5. This is what numbers.txt contains. You can add additional numbers if you want. And then we will create a method, public. It will return an IEnumerable of int read numbers, because we will read those numbers from the disk. We will read it through I/O. A very important concept comes in. You should all know it by now. Asynchronous programming. Async, task off. Important thing, read numbers. I often get asked by students, should we call it read numbers or read numbers async? Well, the .NET team decided to call all methods which return a task blah 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 async. So they have this postfix here. I really don't care in your homeworks or exercises. So you can call it read numbers async if you want. If you want to stick to the same naming concept as Microsoft does. But if you simply call it read numbers and you argue that all your I/O operations are asynchronous, so why bother mentioning it by using this postfix? That's perfectly fine for me too. So this is up to you. You are old enough to make this decision on your own. So then let's read the file. File.read all text async. Very simple. Let's do the await here in front, and let's say var file content equals to. That's good. And we have to specify the file name here, and that will be numbers.txt. Numbers.txt is a text file. Please right-click on it, properties, and make sure that the copy to output directory is set to copy if new. That is important, because only then the numbers.txt file will be copied to the output directory of your class library. And then we have to parse the file content, file content.split, using the comma as the separator. Why? Because we separate the numbers by comma. It's not that complicated. And then we have to transfer it into values. So we can say select. That is the value text. And we simply say int.parse value text. Visual Studio already suggested it. And we can say return. See? Okay. The question is, what do we do with the numbers.txt? The numbers.txt file lives in a certain folder. It lives in the folder, in my case, temp, HDL live, my first unit test, great math library, numbers.txt. Now if we specify the path here, we can either specify an absolute path where we say the whole path with C and temp and all this stuff. We can do that. But we can also use a relative path. But this path will be relative to the DLL once it runs, okay? This is the relative path. And to make sure that the numbers.txt file will be copied to the output directory where your DLL lives, you have to right-click on the file and set the copy to output directory to copy if newer. That will check whether there is a newer file and will copy the numbers.txt to the output directory of our small little math library. You're welcome. If I build this, this project now, and if I go here and open this in the File Explorer, and I go to bin and debug and net6, you will see that I have the DLL here, and I also have the numbers.txt file here. See? So it's copied alongside with the DLL. This is noted in the CS project file. You see that one? You get a new setting in the CS project file where it says numbers.txt copy to output directory. Now let's go into the basic math here and write, let's create a new class. I changed my mind, I'm very sorry, I changed my mind. Let's create a new class here. And this is the basic statistics. Yes. Basic statistics. I like this one. Basic statistics. And again, you also already know the drill. Remove the usings, namespace, if you like that. That's not mandatory. You can decide on your own. Basic statistics. And then we write a small little method. Let's call it public. The return value will be an int. And it says some values from reader, something like this. It creates a reader. It calls reader.readNumbers, stores it in a variable. What did I do wrong? ReadNumbers is an async method. You see it returns task. So async task of int wait. Now we have the numbers. Works pretty well. And at the end, you see, Visual Studio 2022 is really intelligent. It immediately guesses that numbers.sum is what we want to return. Isn't that nice? Visual Studio is so smart in recognizing what we want to do. We just have to press tab and everything is fine. We return the sum of the numbers. Some value from reader. Good. Nice. So now we can write a test for that. So what can we do? We go to the test project here, copy this test project. I will press Ctrl+C, Ctrl+V in order to duplicate our test basic math, and I will simply rename it to test basic statistics. Change the class name, statistics. Change the method name here, and I can remove the rest of the stuff. So now we have a problem. We have a really big problem. We can immediately create the basic statistics. That is correct. Visual Studio correct. Did you see what Visual Studio did? I'm not sure if you consciously recognized how intelligent, how smart IDEs nowadays are. How did they know that the next line that we are going to write is new basic statistics? It recognized it automatically because we named the test properly. See? So if I press enter, tab, and guess what? It recognizes that basic statistics has exactly one method. We are writing the same test here, so it suggests that we call the same method here, tab, and we already have written quite a bunch of code. But now we have the problem. This sum value from reader is an asynchronous method. And this is very good news for you because you simply can change the test signature to async task. It's perfectly fine to make such a method returning a task. xUnit can handle that. The only thing that you are missing is the using statement. And because this is so frequent that I create tasks which do asynchronous stuff, I will move that one, guess where, into my global usings. Oops. This is wrong. This is right. Now I can await it. I can move it into a variable, result. And then I can say assert equal result, and I can check from my numbers txt, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, so let's try 15. Now what do you guess? Will that work? I don't expect an answer from you. It's a rhetorical question. I will simply run it and check it. Let's see. Although we have an asynchronous method, everything is fine. If we take a look, here, bin, debug, net6, you have, where is it? The great math library. And because we defined that the numbers.txt should be copied to the output directory, guess what? We have our numbers.txt file inside of our unit testing project. Now let's try some interesting scenarios with the very simple code that we have just created here. The first scenario that I would like to demonstrate to you is a scenario where I decide to make the numbers reader no longer public. Imagine that I want to keep the numbers reader private inside of the Great Math library. It shouldn't be available to anybody outside of the Great Math library. So I will change the visibility of the class to internal. Okay? This is now internal. If I try to compile everything, it works perfectly fine. We will hit a problem in a minute. The next thing here with the basic statistics, this one, is that now we maybe want to read the numbers not just from a file, but maybe there is another reader which might read numbers from a database, or might read numbers from a web API, or might even not read the numbers from anywhere. It might generate the numbers using a for loop, for instance. If you have this requirement, that there isn't just one numbers reader, but in the future you might have additional numbers readers. What would you change here regarding the numbers reader? Make suggestions. Oh, I see. Overload the read. Okay, one possible answer is, yeah, we could make this one virtual. If we make this method virtual, additional numbers readers could overload read numbers. But I personally would add a second thing. I'm perfectly fine with what you just said, but I would personally, first, before doing that, I would introduce a base class. So what I could do, I could say, let's create a public class, reader base. Let's call it this way. We can make this class abstract, because it does not contain any implementation. Then we can take the signature here of read numbers, put it for instance here, public. Let's make this method abstract in order to say I'm not going to implement it. I just am saying there is a reader base and every class that is a reader has to implement exactly that method. And now we can do exactly that. We can say this is based on reader base, and we can do what you suggested. We can override the read numbers. So if somebody else would like to create a reader, all that she has to do is to derive from reader base and implement the appropriate number here. A second possibility would be, instead of writing an abstract base class and overriding the method, a second possibility is to work with an interface. Let me show you how that would work. I can copy this abstract class and change it to an interface, public interface, reader base. Then I remove the public abstract, something like this, and then I can use the reader base here and remove the override. See? What is the difference between an abstract base class and an interface? Well, in the past, there were huge differences. An interface couldn't contain any code. Whenever a base class comes with some default implementation or helper methods, it was always required to use an abstract base class. But today, in 2021, with C#10, the borders are kind of blurry. You can use interfaces, you can use abstract base classes, and the differences are kind of subtle. So I personally tend more to the interface solution. So I would rather not create an abstract base class, but I would prefer the interface. Why do I say I prefer the interface? Because a class here can have multiple base interfaces, but can have only one base class. So by creating a base class, you are taking this one precious base class thing away from the implementer. By implementing an interface, a class that implements this interface can, without any problem, implement additional interfaces. So there is only single inheritance for classes, but multi-inheritance for interfaces. This is the reason why I, when in doubt, prefer interfaces over abstract base classes. But there are exceptions to this rule. So in my situation, I will go for the interface. So I will not go for the base class. I will comment that out, but I leave it inside of the code. Of course, I will check this code into the GitHub repository. You can decide on your own whether you want to go for the abstract class or the interface. In case of the exam or the Matura, both options are perfectly fine. You can make the decision. And now we can do something which is pretty important for unit testing and writing testable code, because now I can go to the basic statistics and I can, listen closely, decouple. I can decouple the logic of analyzing and reading by, see what I do? By adding a constructor, giving the constructor an, let's put it here, reader base, let's call it reader, put it into a field, remove this one entirely, and now use the reader that we got in the constructor here. So now this business logic can work with any reader. It works with a file reader, it works with a database reader, it works with a number generator, it works with anything that adheres to iReader base. Now let's go back to the test basic statistics. Now the test basic statistics here needs to get a reader. See? iReader base. That's not a problem, right? Because we simply can say new numbers reader, this doesn't work. Why is Visual Studio not happy with us saying new numbers reader? Who has an idea? Who followed along? Yes, exactly. The numbers reader is not public, no longer public. Now there is a nice little possibility for testing such things to make it public for the tests. Let me show you how you do that. You typically add a new file to your solution. Let's call it friends.cs, remove everything. And here we write a top level assembly statement and say InternalsVisibleTo. We need to add a using statement, runtime compiler services, and then we can say our internals are available to my first unit tests. See? And with that, we can allow our test project to access our internals. We make it a friend. We share our internals with our friend assemblies. So if I go now here to our test basic statistics, suddenly numbers readers works, you see? I can show you that one. Here, new numbers reader, and if you look very, very closely, if you go near the screen, then you will see here in this icon, in this small little icon, you will see a heart. Isn't that nice? Visual Studio shows you that this is a method that your friend gave to you. So you like each other. So press enter, everything's fine, and the technical term is InternalsVisibleTo. Okay? Let's give it a try. Let's go to the Test Explorer, run everything, and let's see. It runs, everything is green, we are good. So what have you learned? We can add abstractions, and we will use this abstraction in a second, if we have different kinds of things, like database reader, file reader, generator, then we can use interfaces or abstract base classes. First thing. And the second thing, if some things are internal, we can use InternalsVisibleTo to make it available to other assemblies. Why is this don't worry, it's perfectly fine. Thank you for trying. Yeah? Why is this an integration test? Because a unit test tests a single unit of work. And you said we are specifically testing some value from reader. But I say no. We are testing some value from reader, but we are also testing the numbers reader. Imagine that we would have a numbers reader, a database reader, a web service reader, and a numbers generator. And we would write the test like that. Do we simply just test the sum value from reader? No. We test the integration of the numbers reader, a specific reader, with the sum value from reader. So this is a typical integration test. This is just like, imagine that you have a web API, something like at the exam last week, you had to build the query controller. No, not the query, the questions controller. And the questions controller were accessing the database. So if you write a test for the questions controller, and the questions controller accesses a database, you are building an integration test. Because you integrate the controller with the database layer. If you want to test them separately as a unit, then you have to rip them apart, and in the middle you need exactly the thing that we created here, an interface or an abstract base class. Because this interface or the abstract base class enables you to test the business logic, this one, and the reader, in our case, separately. And this is exactly what we want to do. So what we do in our unit test to make, in our test to make it a unit test, we do the following. Inside of the test basic statistics, we are going to create a private class. Let's call it our test reader, and it implements iReaderBase. Then we get an error, no problem. We generate the necessary method here, see it here. And we simply simulate the existence of a reader. It doesn't really read any data. But what we are going to do is we simply say return task.from result, and here in the from result we simply give back 1 and 2. Oh, sorry. 1 and 2. So we need an as enumerable here, and please do not forget to add system link. And now it's fine. As you can see, the test reader is now returning the numbers 1 and 2. So we are not really reading anything from the underlying file reader, but really we are simulating the existence of a reader returning 1 and 2 as an enumerable. And because it needs to be a task, what we return, we say at the left-hand side, task.fromResult. So this is a kind of recipe that you can use in all those cases. You say task.fromResult, and with that you generate the test reader. It's also often referred to as a mock object, and in our case it returns the IEnumerable using the as enumerable. With that done, we can change our integration test into a unit test by changing the reader to a test reader. We now know exactly what the test reader returns, namely 3, because we pass in the numbers 1 and 2. So we kind of ripped apart the connection between our sum value from reader and our reader itself by adding the mock object or test object and using it instead of the numbers reader. So now we really have a unit test instead of an integration test. That was the whole point that I wanted to tell you. I wanted to show you. We use an interface to loosely couple the business logic from some value from reader with the reader itself that provides data, in our case from a file, but in practice it could come from a database, from a web API, or even generate some values. Last but not least, in order to make our testing suite complete, we copy the basic statistics and add a unit test for the numbers reader. So add the test numbers reader class here. Let's rename the method and call it test read numbers, because this is what we do. And then we delete the code here and replace it with the reader. So we new up a numbers reader because this is what we want to test now. We assert equal the expected outcome. In our case, we exactly know, I made a mistake here, sorry. So it is assert.equal, this is the correct one. We simply say what is the input of the expected input of the file, that is 1, 2, 3, 4, 5, because this is what we had in the file. And then we simply say reader.readNumbers, and don't forget, it's an async method, so await it. With that, we now have two different unit tests. We have a unit test for the numbers reader, which will hopefully succeed. Give my computer a second. And here we are. We have a green check. We have a unit test for the reader, and we have a unit test for the business logic, which is summing up values coming from a reader. Here you see the sum value from reader unit test. The decoupling is done with the interface, with the iReader. And with that, we have unit tests with facts, theories for the numbers reader and for the basic stats. The decoupling mechanism was the interface, the iReader base that you see here. By introducing the iReader base, we decoupled the business logic from the reader. I repeat myself consciously to make this point very clear. Don't get me wrong, it's perfectly fine to write integration tests. But in this case, we decided to write unit tests to isolate the calculation and the business logic. Finally, I would like to draw your attention to a very, very widely used framework, which is called Mock. You see it here? It's Mock v5. That's the upcoming version of Mock. The current stable version, it's called Mock 4. I use it very frequently. It's widely used, and mock makes it much easier to create mock object or test classes like the one that we created for our reader. So you see, this is widely used. More than 100,000 projects on GitHub use mock. So in practice, when you do practical work, maybe for your internship, you shouldn't write a test reader like that. In practice, you should use the mock library in order to generate a mock object like the test reader based on the interface iReaderBase. We will not go into the details here on mock because our time is limited, but I want to point out the importance of the mock framework. So you wouldn't need to write that class. This would be generated by mock, okay? And that was our code for today. We have learned a lot about xUnit, about how to structure libraries, how to write unit tests, how to turn integration tests into unit tests, and I hope it was useful for you. We will now go into a question and answer session, but before, I would like to tell you a little bit about your homework.